Good evening and welcome. Tonight, as the stars begin their slow procession across the darkening sky, we turn our attention towards something extraordinary, something that whispered across the void on a single autumn day in 2025A signal, a mystery, a moment when the universe seemed just for 11 minutes to speak in a language we almost recognized. This evening we begin at the beginning, not with the whisper itself, but with the instrument that heard it, the remarkable telescope that stood sentinel in the quiet wilderness of South Africa, listening patiently to the cosmic radio hum that fills the space between worlds. Because before we can understand what was heard, we must first understand how we learn to listen. Far from the glow of cities, nestled in the vast and ancient landscape of the Karoo Desert in South Africa, stands an array of 64 radio dishes, each one, gleaming white against the rust-coloured earth, points silently toward the heavens. Together they form the Meerkat Radio Telescope, operated by the South African Radio Astronomy Observatory. The name Meerkat is a gentle nod to the small, watchful creatures native to the region, the meerkats, who also stand alert, scanning the horizon for signals of danger or opportunity. But these dishes scan for something far more distant. They listen to the whispers of the cosmos, the faint radio waves that travel across unimaginable distances, carrying with them the stories of stars, galaxies, and perhaps, just perhaps, something more. Meerkat is not just any radio telescope. It is exquisitely optimized for a specific slice of the radio spectrum known as the L-band, which spans frequencies from 0.9 gigahertz all the way to 1.67 gigahertz. To put that in perspective, these are the same kinds of radio waves your mobile phone might use, but Meerkat listens to them with a sensitivity so profound it could detect the faint electromagnetic whisper of a single snowflake falling on the surface of the moon, if snowflakes fell there, and if they happened to emit radio waves. Within this L-band lies something profoundly important, the frequencies associated with the fundamental chemistry of the universe, the building blocks of water, the spectral signatures of hydrogen and hydroxyl radicals, the very molecules that, when combined, create water itself. And water, as we know, is the elixir of life. Wherever we find water, we find the possibility of biology, of complexity, of stories written in chemistry rather than ink. It was on October 24th, 2025, that Meerkat turned its gaze toward an object with an unusual name, 3I Atlas. The name itself sounds both mechanical and poetic, a designation that tells us this was the third confirmed interstellar object ever detected, an icy visitor from beyond our solar system, passing through our cosmic neighborhood on a trajectory that would never return. Interstellar objects are extraordinarily rare. For most of human history, we believe that all comets and asteroids were born here, within the sun's gravitational embrace. But in recent years, we have begun to detect these wanderers, these travelers from distant star systems, drifting through the space between stars, occasionally crossing paths with our own sun. Each one is a messenger, carrying with it clues about the chemistry, the physics, and perhaps even the possibility of life in star systems we will never visit. On that particular October day, 3I Atlas was positioned in one of the most challenging observational environments imaginable. It was passing near what astronomers call solar conjunction, a moment when the object is aligned almost directly with the sun as seen from Earth. In fact, It was only 3.76 degrees away from the sun in the sky. To give you a sense of scale, that is roughly the width of 3 fingers held at arm's length. For a radio telescope, this proximity to our star creates an ocean of noise. The sun is not quiet. It roars with radio energy, crackling and hissing across the spectrum like a cosmic bonfire. Detecting anything meaningful in that environment is akin to hearing a whisper in a thunderstorm. Yet Meerkat succeeded. The signal was captured, clean, distinct, and undeniable. The detection itself was a significant technical achievement, a testament to the precision of the instrument and the skill of the scientists who operate it. But the story does not end with the detection. In fact, it barely begins there. Crucially, this observation occurred within the context of an emerging and fascinating practice in modern astronomy known as commensal SETI, which stands for Search for Extraterrestrial Intelligence, has long been a field dedicated to scanning the skies for signals that might indicate the presence of advanced civilizations beyond Earth. Traditionally, SETI required dedicated telescope time, precious hours when an instrument would be devoted entirely to the search for alien transmissions. But in recent years, astronomers have adopted a more efficient approach. Commensal SETI allows multiple research programs to share the same observational data simultaneously. While one team studies the natural chemistry of a comet, another team can search the same data stream for anomalies, for patterns, for anything that defies the expected noise of nature. This means that even during routine astrophysical surveys, during the patient cataloguing of distant galaxies, or the spectral analysis of interstellar gas clouds, the search for intelligence continues quietly in the background. It is a beautiful marriage of curiosity and efficiency, and it ensures that if something unusual appears, even for a fleeting moment, it will not go unnoticed. On that October afternoon, as 3i Atlas drifted past the sun, Meerkat was doing exactly that. It was recording the radio spectrum of the comet, measuring the natural emissions and absorptions that occur when sunlight heats ice and releases gas into space. But simultaneously, algorithms were analyzing that same data stream, searching for coherence, for structure, for anything that might hint at artificiality. And then, for 11 minutes, something happened, something that would not be fully understood until much later, a signal, or perhaps more accurately, a pattern within the signal. 2 tones alternating at precise intervals, clean, organized, repeating. But before we can unravel that mystery, before we can ask whether those 11 minutes represent the voice of chemistry or the whisper of intention, we must first understand what Meerkat actually confirmed, what the data undeniably showed. And that confirmation, as we will see, is both beautifully simple and profoundly ironic, because the universe, it turns out, speaks the language of water, and it does so precisely in the frequency range where humanity has long believed intelligent civilizations might choose to communicate. That overlap, that cosmic coincidence, is what makes 3i Atlas not just a scientific curiosity, but a philosophical riddle. A question written in radio waves, a whisper that forces us to ask, what is the difference between the chemistry of life and the signal of intelligence? Tonight, we begin to listen, carefully, patiently, with the same quiet attention that Meerkat brings to the cosmos every single night, because in the space between stars, in the frequencies where hydrogen meets hydroxyl, the universe is always speaking, and sometimes Just sometimes it says something we cannot ignore. Now that we understand the instrument and the moment, let us turn to what was actually detected, what the data revealed with absolute clarity. Because before we can explore the whisper, the tantalizing possibility of something more, we must first acknowledge what science confirmed beyond any doubt. And that confirmation is, in its own way, a story of cosmic chemistry as ancient as the stars themselves. The Meerkat telescope, as we discussed, was listening carefully to 3I Atlas as it passed near the Sun. And what it heard, captured with crystalline precision, was the unmistakable signature of hydroxyl radicals. Hydroxyl, written in the language of chemistry as OH, is a molecule consisting of one oxygen atom bonded to one hydrogen atom. It is not water, but it is water's closest cousin, a single broken piece of the molecule that makes oceans possible. The signal manifested as 2 distinct spectral lines, 2 specific radio frequencies, where the hydroxyl molecules were absorbing energy from the background radiation of space. These frequencies were recorded at 1.665 GHz and 1.667 GHz. To the untrained eye, these numbers might seem arbitrary, mere coordinates on an invisible map. But to astronomers, these frequencies sing with meaning. They are the natural resonance of hydroxyl molecules, the frequencies at which they absorb and emit radio energy when floating freely in the cold vacuum of space. The physical mechanism behind this detection is beautifully straightforward, a textbook example of cometary activity that has been observed countless times in our own solar system. As 3I Atlas approached the Sun, the increasing warmth from our star began to heat the object's icy surface. Imagine a snowball left in the sunshine. Slowly the frozen water begins to sublime, transforming directly from solid ice into vapor without passing through a liquid phase. This is precisely what happens to comets as they journey toward the inner solar system. The sublimating water molecules, freshly liberated from their frozen prison, immediately encounter the harsh ultraviolet radiation streaming from the Sun. This ultraviolet light is energetic enough to break chemical bonds, and it swiftly tears the water molecules apart, splitting each H2O into fragments. Among these fragments are the hydroxyl radicals, those one oxygen, one hydrogen molecules that now float freely in the thin halo of gas surrounding the comet. This halo, glowing faintly with reflected sunlight and fluorescing with its own chemical energy, is called the coma. Once liberated, these hydroxyl molecules begin to interact with the radio energy permeating space. At their characteristic frequencies, 1.665 and 1.667 GHz, they absorb photons from the background radiation. This absorption creates dips in the spectrum, dark lines in the otherwise continuous rainbow of radio light. These are absorption lines, and they are as distinctive as fingerprints. Each molecule in the universe has its own unique set of frequencies, its own signature written in light. For 3I Atlas, the detection of these hydroxyl lines was definitive proof of cometary activity. It confirmed that the object was not a bare rock tumbling through space, but rather a volatile, rich body, an icy wanderer carrying frozen water from a distant star system. This water, formed perhaps billions of years ago in the cold nursery of another sun, had travelled across the interstellar void, only to sublimate and reveal itself as it passed through our solar system. But the story becomes even more precise, more beautiful in its detail. The spectral lines were not centered exactly at the expected frequencies. They were shifted, stretched by the Doppler effect, that fundamental phenomenon of physics where motion changes the observed frequency of waves. Just as the pitch of a siren drops as an ambulance speeds away from you, the frequency of light shifts when its source is moving relative to the observer. For the hydroxyl lines detected from 3I Atlas, the Doppler shifts were measured with exquisite precision. The 1.665 GHz line was shifted by negative 15.59 kilometers per second, with an uncertainty of only 0.16 kilometers per second. The 1.667 GHz line showed a shift of negative 15.65 kilometers per second, plus or minus 0.17. The negative sign indicates that the object was moving toward Earth along the line of sight, though its overall trajectory was carrying it through the solar system at a much higher speed. This is where the verification becomes truly compelling. On the day of observation, October 24th, 2025, 3I Atlas was traveling at approximately 98 kilometers per second relative to Earth. But this was its total velocity through space. The Doppler shift depends only on the component of that velocity along the line of sight, the direction from the comet directly toward or away from Meerkat. Given the geometry of the observation, the angle between the object's motion and the telescope's line of sight was calculated to be approximately 9.2 degrees. When astronomers performed the trigonometry, accounting for this angle and projecting the velocity onto the line of sight, the predicted Doppler shift matched the observed shift almost perfectly. It was a moment of mathematical harmony, where theory and observation aligned with breathtaking precision. The hydroxyl molecules were moving exactly as they should, carried along by the comet's velocity through space, their spectral lines shifted by precisely the amount predicted by the laws of motion and light. This agreement is not a minor detail. It is the cornerstone of scientific verification. If the observed Doppler shifts had been inconsistent with the known velocity of 3I Atlas, it would have suggested something deeply anomalous, something requiring extraordinary explanation, but instead, the data fits seamlessly into the framework of natural cometary activity. The hydroxyl molecules were exactly where they should be, moving exactly as they should move, absorbing light exactly at the frequencies predicted by quantum mechanics. And so, the scientific community reached a consensus. The radio signal detected by Meerkat on October 24th was the natural emission of hydroxyl radicals produced by the sublimation of water ice as 3I Atlas passed through the warmth of the inner solar system. It was chemistry, pure and beautiful. The universe, once again, demonstrating that it obeys the laws we have painstakingly uncovered through centuries of observation and thought. But here is where the story takes its first turn toward mystery. Because the frequencies where hydroxyl absorbs, 1.665 and 1.667 gigahertz, do not exist in isolation. They reside within a very special region of the radio spectrum, a region that humanity has long considered the most promising place to search for messages from extraterrestrial civilizations. This region is known, with poetic irony, as the waterhole. The waterhole spans from 1.420 gigahertz, the emission line of neutral hydrogen, to 1.666 gigahertz, the emission line of hydroxyl hydrogen and hydroxyl, H and OH. the two halves of water separated by a narrow band of radio frequencies. It was Bernard Oliver, an engineer and visionary, who coined the term in 1971. He suggested that any intelligent civilization seeking to communicate across the stars would naturally choose this frequency range. Why? Because water is universal. It is the foundation of life as we know it, the solvent in which chemistry becomes biology. And because this band of frequencies is relatively quiet, a natural oasis in the noisy radio spectrum where signals can travel clearly across the vastness of interstellar space. For decades, the waterhole has been the favoured hunting ground for SETI. Radio telescopes have scanned this region tirelessly, listening for the faint, coherent signal that might indicate the presence of another technological civilization. And now, here, in this very same frequency range, we detect the unmistakable signature of water chemistry, the hydroxyl radical born from sublimating ice, absorbing energy at precisely the frequencies where we have been listening for intelligence. This is the waterhole paradox. The very frequencies that make the most sense for communication are dominated by the noise of natural chemistry. The language of life, written in hydroxyl and hydrogen, fills the spectrum where we hoped to hear the voice of intelligence. And 3I Atlas, an interstellar comet, has reminded us of this profound irony. As we move forward, we must hold two truths in our minds simultaneously. The first is that the signal was confirmed, verified, and understood. It was hydroxyl. It was chemistry. It was nature. But the second truth is more elusive, more haunting. For 11 minutes, something else may have been present, a structure within the noise, a pattern that cannot be explained by thermal broadening alone. And that possibility, however faint, demands that we listen more carefully still. To truly understand what Meerkat detected, to distinguish between the whisper of chemistry and the possibility of something more, we must look even deeper into the physics of light and molecules. Because every spectral line, every absorption feature captured by a telescope, carries within it a story, not just of what the molecule is, but of how it moves, how it breathes, how it exists in the fabric of space. This brings us to one of the most elegant confirmations in the entire 3I Atlas observation, the analysis of the spectral line widths, the physical characteristics that tell us whether these hydroxyl molecules were behaving exactly as natural cometary chemistry predicts, or whether something deeper, something stranger, might be hidden in the data. When molecules float freely in space, they are not standing still. They are in constant motion, jittering and vibrating with thermal energy. The hotter the gas, the faster the molecules move, and this motion has a direct effect on the light they absorb or emit. Imagine standing beside a highway, listening to cars pass by. Each car's engine has a specific pitch, but as it speeds toward you, the sound waves compress, and the pitch rises. As it speeds away, the waves stretch, and the pitch drops. This is the Doppler effect, the same phenomenon that shifts the frequency of light from moving objects. In a cloud of gas molecules, each individual molecule is moving in a slightly different direction, at a slightly different speed. Some are moving toward the telescope, some away, some sideways. When they absorb light, each one creates an absorption line at a slightly different frequency, shifted by its own unique velocity. The result is that the spectral line, which would be infinitely narrow if all the molecules were perfectly still, becomes broadened. It smears out across a small range of frequencies, creating a gentle curve rather than a razor-sharp dip. This broadening is called thermal broadening, and it is exquisitely sensitive to temperature. The width of the spectral line, measured by what astronomers call the full width at half maximum, tells us directly how fast the molecules are moving, and from that speed we can calculate the temperature of the gas. It is a thermometer written in light, a way to measure the warmth of distant molecules without ever touching them. For 3I Atlas, this calculation becomes a powerful test of whether the signal was truly natural. At the time of observation on October 24th, the object was approximately 1.38 astronomical units from the Sun. An astronomical unit is the distance from the Earth to the Sun, about 150 million kilometers. At this distance, the warmth from our star decreases according to a well-understood law. The intensity of sunlight falls off with the square of the distance, so an object twice as far from the Sun receives only 1/4 of the heat. Using standard thermodynamic models, astronomers calculated the expected surface temperature of 3I Atlas at this distance. The result was approximately 230 Kelvin. To give you a sense of scale, that is about minus 43 degrees Celsius, or minus 45 degrees Fahrenheit cold by human standards, but warm enough for frozen water ice to begin sublimating, releasing vapor into space. At this temperature, the hydroxyl molecules escaping from the surface would have a characteristic thermal velocity. The lighter the molecule, the faster it moves at a given temperature. For hydroxyl, with its mass of 17 atomic mass units, the predicted thermal speed at 230 Kelvin corresponds to a spectral line width of approximately 0.8 kilometers per second. This is a precise prediction. It flows directly from the laws of thermodynamics and the known distance of the object from the Sun. It requires no free parameters, no adjustments, no guesswork. The physics tells us exactly what the line width should be if the signal is natural, thermal emission from a sunlit comet. And so, the critical question becomes, what did Meerkat actually measure? The observed line widths for the two hydroxyl features were 0.88 kilometers per second, plus or minus 0.37. For the 1.665 gigahertz line, and 1.26 kilometers per second, plus or minus 0.40 for the 1.667 gigahertz line. Take a moment to appreciate the agreement here. The theoretical prediction was 0.8 kilometers per second. The measurements came in at 0.88 and 1.26, with uncertainties that overlap beautifully with the predicted value. This is not just close. This is the kind of agreement that makes scientists sit back and smile, because it means the universe is behaving exactly as the equations predict. This thermal consistency is, in many ways, the most compelling evidence that the hydroxyl signal from 3I Atlas was entirely natural. The spectral lines were not artificially narrow, which would suggest a coherent engineered source. They were not anomalously broad, which might indicate turbulence or some exotic physical process. They were precisely as wide as they should be, given the temperature of the gas and the thermal motion of the molecules. It is worth pausing to consider what would constitute an anomaly if the lines had been extremely narrow, with widths measured in meters per second rather than kilometers per second. It would have suggested a cold, quiescent source, or perhaps even a coherent laser-like emission that defied thermal physics. Such narrowness is the hallmark of intentional signals, of transmissions engineered to concentrate energy into the smallest possible bandwidth for maximum detectability across interstellar distances. But that is not what was observed. The hydroxyl lines were thermally broadened, consistent with molecules released from a warm surface, and moving freely under the influence of thermal energy. The object's distance from the Sun, its surface temperature, and the observed spectral widths all fit together in a seamless chain of physical reasoning. It is the kind of internal consistency that turns speculation into confirmation. This does not mean, however, that the story is complete, because while the hydroxyl absorption lines were confirmed and understood, the narrative of the 11-minute whisper suggests something else may have been present, something narrower, something structured, something that did not show up in the initial analysis of the broad spectral features. The hydroxyl lines occupy a bandwidth of approximately 1.6 MHz, corresponding to the thermal broadening we have discussed. But within that bandwidth, hidden perhaps beneath the dominant natural signal, could there have been a much narrower component, a signal so spectrally sharp that it required specialized processing to detect? This is where the distinction between astrophysical noise and technological coherence becomes critically important. An artificial signal, if it existed, would likely be orders of magnitude narrower than the thermal lines. It might occupy only a few hertz or millihertz of bandwidth, a whisper within a whisper, detectable only through sophisticated algorithms designed to search for coherence in the data stream. Such a signal would not invalidate the hydroxyl detection. The two could coexist, occupying the same observational window, but existing at vastly different scales of spectral resolution. This is the heart of the Three-Eye Atlas mystery. The confirmed natural signal is indisputable. The thermal physics checks out perfectly. The Doppler shifts align with the object's motion. The line widths match the predicted temperature. Every piece of the puzzle fits together to tell the story of a comet releasing water vapor as it passes through the inner solar system. Yet the possibility remains that within this natural symphony, within the chorus of thermally broadened hydroxyl molecules, there was a single note, pure and clear, that lasted for exactly 11 minutes, a note that defied the statistics of randomness, a note that, if it was real, would force us to ask whether Three-Eye Atlas was more than it appeared to be. As we prepare to move forward into the deeper questions of signal structure and intentionality, remember this foundation. The hydroxyl detection is real, the thermal broadening is real, the physics is consistent, elegant, and confirmed. But science is not about certainty. It is about asking what else might be true, what else might be hidden in the data, waiting patiently to be found. Now we arrive at the heart of the cosmic irony, the place where chemistry and intention seem to occupy the same space, speaking in the same frequencies, blurring the line between the language of nature and the possibility of design. This is the waterhole paradox, and it is both beautiful and deeply troubling for those who search the skies for signs of intelligence beyond Earth. The waterhole is not a physical place. It is a region of the electromagnetic spectrum, a narrow band of radio frequencies that stretches from 1.420 GHz to 1.666 GHz. These numbers are not arbitrary. They mark the boundaries between two of the most fundamental molecular signatures in the universe. At the lower edge, at 1.420 GHz, lies the emission line of neutral hydrogen, the simplest and most abundant element in existence. At the upper edge, at 1.666 GHz, lies the emission line of hydroxyl, that broken fragment of water we have already come to know so well. Hydrogen and hydroxyl, H and OH. Together, they spell H2O, water, the molecule upon which all known life depends. And between them lies this quiet band of frequencies, this cosmic oasis, where the radio sky is naturally calm, where signals can propagate clearly across the vast distances between stars without being scattered or absorbed by interstellar gas and dust. In 1971, an engineer named Bernard Oliver, who was then the Director of Research and Development at Hewlett-Packard, proposed that this frequency range would be the most logical place for extraterrestrial civilizations to send their messages. His reasoning was elegant in its simplicity. Any technological species that arises in the universe, if it is based on chemistry similar to ours, will recognize water as fundamental. Water is the solvent of life, the medium in which complex molecules dissolve and interact, the substance that makes biology possible. And so, Oliver argued, the spectral signatures of water's components would serve as a universal meeting point, a frequency range that any intelligent species would naturally investigate. He called it the water hole, evoking the image of animals gathering around a desert watering hole, a place where different species come together out of shared necessity. In the radio spectrum, the water hole would be where civilizations gather, where they would logically choose to transmit and listen because it represents something universally recognizable. A Schelling point, as game theorists would say, a focal point of coordination that emerges naturally from shared knowledge. For more than half a century, the search for extraterrestrial intelligence has focused much of its attention on this frequency range. Radio telescopes around the world have spent countless hours listening within the water hole, scanning for narrowband signals, for patterns that might indicate technological origin. The logic is compelling. If we were trying to announce our presence to the galaxy, we would likely choose these frequencies, and if another civilization were trying to reach us, they would likely make the same choice. But here is the profound irony that 3i Atlas has brought into sharp focus. The water hole, this supposedly quiet cosmic meeting place, is not quiet at all. It is filled with the voice of chemistry. The hydroxyl radical, born from the breakup of water molecules in comets, in molecular clouds, in the atmospheres of planets and moons, absorbs and emits radio energy at precisely the frequencies we have designated for communication. The natural universe is already speaking in this range, broadcasting its chemical processes across interstellar space. When Meerkat detected the hydroxyl lines from 3i Atlas at 1.665 and 1.667 GHz, it was hearing exactly this phenomenon. The fundamental signature of water-based chemistry, the dissociation of H2O into OH under the influence of sunlight, was manifesting precisely where humanity has been listening for intelligence. The language of life, the chemical processes that might someday lead to biology on distant worlds, occupies the same frequencies where we hope to hear the deliberate transmissions of technological civilizations. This creates a profound challenge for SETI. How do we distinguish between the natural radio noise of cometary outgassing, of molecular clouds glowing with hydroxyl emission, and the intentional signal of an extraterrestrial beacon? Both occupy the water hole. Both generate radio waves at the characteristic frequencies of hydrogen and hydroxyl. The cosmic meeting place we chose for its universal recognizability turns out to be crowded with the chatter of chemistry. The solution, as astronomers have come to realize, requires sophisticated filtering and analysis. It is not enough to simply detect a signal within the water hole. We must examine its characteristics in exquisite detail. Is the signal thermally broadened, smeared across a wide range of frequencies by the random motion of molecules? Or is it spectrally narrow, concentrated into a precise frequency with a coherence that defies natural thermal processes? Does it drift in frequency over time, following the predictable Doppler shift of an astronomical source moving through space? Or does it remain locked to a specific frequency, compensated perhaps by a transmitter adjusting for its own motion? These are the questions that separate astrophysical noise from techno-signatures, and they are precisely the questions that make the 3-eye atlas detection so intriguing. Because while the confirmed hydroxyl absorption lines were thermally broadened and entirely consistent with natural cometary activity, the narrative of the 11-minute whisper suggests something else may have been present, something that was not thermally broadened, something that exhibited structure, synchronization, precision. If such a signal existed, hidden within or alongside the dominant hydroxyl features, it would represent exactly the kind of anomaly that SETI protocols are designed to detect a narrowband component, perhaps only a few hertz or millihertz wide, embedded in the natural spectrum like a whisper beneath a waterfall. The challenge is that detecting such a signal requires reprocessing the raw data with algorithms specifically designed to search for coherence at the finest spectral resolutions, beyond what standard astronomical processing would reveal. This is where the waterhole paradox becomes not just a philosophical observation, but a practical problem. Future SETI searches cannot simply scan the waterhole for any and all signals. They must filter out the dense, Doppler-shifted astrophysical noise generated by comets, by molecular clouds, by all the natural chemistry that pervades interstellar space. They must be able to distinguish between the thermal broadening of hydroxyl molecules moving at hundreds of meters per second and the laser-like precision of an engineered transmission. The essential ambiguity here is profound. The language of complex water-based chemistry, the very processes that might give rise to life, occupies the frequency space we have designated for intelligent communication, nature, and intention overlap in the water hole, and 3-eye atlas, an interstellar comet broadcasting its chemical composition as it passes through our solar system, stands as a perfect example of this cosmic coincidence. Yet within this ambiguity lies an opportunity, because if we can learn to separate the natural signals from the artificial ones, if we can develop the tools and techniques to recognize coherence amid the noise, then the water hole becomes not a confusing cacophony, but a rich landscape where both chemistry and communication might coexist. The presence of hydroxyl does not negate the possibility of a beacon. It simply means we must listen more carefully, with greater precision, with algorithms capable of finding the narrowband whisper within the thermally broadened chorus, And so, the waterhole paradox becomes a call to deeper inquiry. The universe speaks the language of water at precisely the frequencies where we seek the voice of intelligence. Whether this is mere coincidence or something more profound, a hint that life and mind naturally converge on the same cosmic wavelengths remains an open question. But one thing is certain. We cannot afford to assume that every signal in the waterhole is natural, nor can we afford to assume that every anomaly is artificial. We must investigate each one with the same patient, rigorous attention that Meerkat brought to Three-Eye Atlas on that October afternoon, because somewhere in the space between chemistry and intention, between the thermal motion of molecules and the deliberate encoding of information, lies the answer to one of humanity's oldest questions. Are we alone? And if we are not, will we recognize the signal when it finally arrives? Having established the irony of the waterhole, we now face the most difficult question of all. How do we tell the difference between a whisper from the cosmos and a message from another mind? How do we distinguish the thermal motion of molecules, the random vibrations of hydroxyl radicals drifting through space, from the deliberate transmission of an intelligence that has travelled light years to announce its presence? This is not a philosophical question. It is a practical one, refined over decades of listening, of false alarms and hard-won lessons, and it requires a framework, a systematic way of evaluating signals that allows us to separate the noise of nature from the possibility of intention. The narrative of Three-Eye Atlas suggests that for 11 minutes, something structured was present, two tones alternating at exact intervals, a repeating pulse, clean, organized, synchronous. These are words that do not belong to thermal physics. They belong to the language of design, of programming, of deliberate encoding. And so we must ask, what would constitute proof? What characteristics would elevate this signal from intriguing anomaly to credible technosignature? The answer lies in coherence. In the physics of electromagnetic radiation, coherence refers to the purity of a signal, its concentration into a narrow band of frequencies. Natural astrophysical processes, driven by thermal energy and random motion, produce signals that are spectrally broad. The hydroxyl lines we confirmed from Three-Eye Atlas, for instance, spanned approximately 1.6 MHz due to thermal broadening. That is 1,600,000 Hz, a substantial chunk of the radio spectrum, but an intentional transmission designed to be detected across interstellar distances would be very different to maximize its detectability, to concentrate its energy into the smallest possible space on the electromagnetic canvas. An artificial signal would be extraordinarily narrow. We are talking about bandwidths measured in hertz or millihertz or even microhertz. A single pure tone, like the note from a perfect tuning fork, held steady across the void. This narrowness is not accidental. It is a consequence of engineering efficiency. If you wish to send a signal that can be detected billions of kilometers away, you must focus your energy. Broadcasting across a wide bandwidth dilutes your power. Spreading it thin, but concentrate that same energy into a razor-thin frequency channel, and suddenly your signal rises above the noise, like a lighthouse beam cutting through fog. This is the first criterion in the SETI vetting framework: bandwidth. A natural signal will be thermally broadened, its width determined by the temperature and mass of the molecules producing it. An artificial signal will be orders of magnitude narrower, limited only by the stability of the transmitter and the Doppler effects of relative motion. But narrowness alone is not enough. The universe contains some naturally coherent phenomena. Pulsars, for instance, those rapidly rotating neutron stars, emit pulses of radio energy with astonishing regularity. Astrophysical messiers, regions of space where molecules amplify microwave radiation like a cosmic laser, can produce spectrally narrow lines under specific conditions. Fast radio bursts, those mysterious millisecond flashes from distant galaxies, exhibit coherence that still defies complete explanation. So we need additional criteria. The second is drift. As the Earth rotates and orbits the Sun, and as the source of any distant signal moves through its own orbit or trajectory, the observed frequency of that signal will change continuously due to the Doppler effect. This drift is predictable, calculable. If the signal originates from deep space, from a point fixed relative to the stars, we can model how its frequency should change minute by minute as our planet turns and our motion through space alters the relative velocity. A confirmed technosignature must exhibit this drift. It must follow the pattern predicted by celestial mechanics, and crucially, it must disappear when the telescope is pointed away from the source. This is the on-off test, the most basic verification that the signal is coming from a specific location in the sky, rather than from interference on Earth or in the telescope itself. When Meerkat detects a signal, the first question is always, does it persist when we point elsewhere? If it does, it is almost certainly terrestrial radio frequency interference, pollution from our own technology, the hum of cell towers and satellites and passing aircraft. But if it vanishes when the telescope moves away from the target and reappears when the telescope returns, then we know we are hearing something from far-field space, something genuinely distant. For 3i Atlas, the confirmed hydroxyl signal passed this test. It was positionally aligned with the comet. It appeared when Meerkat pointed at the object's coordinates and would have faded as the telescope moved away. This is strong evidence for a genuine far-field origin, confirming that the radio waves were indeed coming from the direction of the interstellar visitor. But the alleged whisper, the 11-minute structured pulse, would require even more rigorous verification. If such a narrow band component existed, distinct from the broad hydroxyl features, it would need to demonstrate all the characteristics we have discussed. Extreme spectral narrowness, continuous Doppler drift consistent with 3i Atlas's velocity, and most importantly, temporal structure that defies statistical randomness. This brings us to the concept of synchronization natural processes, even when they produce regular patterns like the pulsations of stars or the oscillations of molecules, arise from physical dynamics that are ultimately chaotic at small scales. Thermal motion is random. Molecular collisions are stochastic. Even when these processes average out to produce predictable macroscopic behavior, the underlying randomness ensures that perfect synchronization, exact repetition at precise intervals, is vanishingly unlikely. But a program transmission can be perfectly synchronous. A computer-controlled beacon can emit pulses timed to nanosecond precision, alternating between frequencies with mathematical exactness. This is the signature of intent, the fingerprint of design. When randomness is replaced by regularity, when chaos gives way to pattern, we are no longer looking at thermal physics. We are looking at information. The description of the three-eye Atlas whisper, if accurate, suggests exactly this kind of synchronization. Two tones alternating at exact intervals for 11 continuous minutes, not drifting, not fluctuating, exact. This temporal precision is perhaps the most compelling aspect of the entire narrative, because it is something that natural astrophysical processes simply cannot produce with such consistency, and yet we must remain cautious. The history of SETI is filled with signals that seemed compelling until they were explained. The famous WOW signal of 1977, a powerful narrowband detection that appeared for 72 seconds and never repeated, remains unexplained to this day. But a single, non-repeating event, however intriguing, does not meet the standard of proof. It could be interference. It could be instrumental error. It could be a natural phenomenon we do not yet understand. This is why the scientific community demands reproducibility. A true technosignature must be detected multiple times, ideally by independent instruments in different locations. It must survive the scrutiny of peer review, the skeptical examination of experts who have spent their careers distinguishing signal from noise. For Three-Eye Atlas, the path forward is clear. The raw data from Meerkat, archived in its full time and frequency resolution, must be reprocessed with algorithms specifically designed to search for narrowband coherence. This is not the standard astronomical processing that revealed the hydroxyl lines. It is a deeper, more computationally intensive analysis, searching for patterns at scales measured in hertz rather than megahertz. Organizations like Breakthrough Listen maintain vast archives of radio telescope data precisely for this purpose. They employ machine learning algorithms that can sift through petabytes of information, searching for anomalies that human eyes might miss if the 11-minute whisper was real. If it exists in the data, these techniques can find it. And if they do, if a narrowband, synchronized, positionally confirmed signal emerges from the reanalysis, then Three-Eye Atlas will have given us something far more profound than a confirmed comet. It will have given us the first credible evidence that we are not alone, that somewhere among the stars, another mind has built a machine, pointed it toward the cosmos, and whispered across the void. But until that moment, we remain in the space of possibility. The hydroxyl is confirmed. The thermal physics is verified. The waterhole irony is undeniable. And the whisper, tantalizing and structured though it may be, awaits its final verdict in the archives. Now we must confront the whisper directly, not as confirmed fact, but as hypothesis, as a possibility that demands rigorous examination, careful thought, and a willingness to entertain the extraordinary while maintaining our commitment to evidence. Because the description of what may have occurred during those 11 minutes, if accurate, does not fit easily into the framework of natural cometary chemistry. Two tones alternating at exact intervals, a repeating pulse, clean, organized, lasting precisely 11 minutes before vanishing back into silence. These words carry weight because they describe something that thermal physics cannot easily explain. Random molecular motion does not produce exact intervals. Natural resonances do not synchronize themselves with clockwork precision. And hydroxyl molecules, drifting freely in the cold vacuum around a comet, do not organize themselves into alternating patterns. If such a signal was indeed present, hidden perhaps within or alongside the broader hydroxyl absorption features, it would represent something categorically different from what we have confirmed. The confirmed signal, as we have established, was thermally broadened across approximately 1.6 MHz, but an alternating pulse, a structured transmission, would require spectral narrowness far beyond what thermal motion allows. Consider what a highly narrow band, highly coherent pulse would look like in the data. Instead of the gentle curve of a thermally broadened absorption line, you would see something resembling a laser beam in frequency space, a single sharp spike, or perhaps two spikes, if the description of alternating tones is accurate, each occupying only a few hertz or perhaps even millihertz of bandwidth. This is orders of magnitude narrower than the natural hydroxyl features, so narrow that it might not even appear in the standard astronomical processing pipelines designed to detect molecular lines. This is why the initial detection might have been missed or discounted. Radio astronomy software is typically optimized to find spectral features at certain characteristic widths. If you are searching for cometary emissions, you tune your algorithms to look for lines broadened by thermal motion, by turbulence, by the natural processes that govern gas dynamics. An extremely narrow signal, sitting quietly beneath that broader feature, might simply be filtered out as noise or instrumental artifact unless you specifically search for it, but the description suggests that someone did notice it. That during commensal SETI processing, running in parallel with the standard astronomical analysis, something anomalous was flagged. This makes sense within the context of how modern SETI operates. While one team analyzes the comet's chemistry, another team runs entirely different algorithms on the same data stream, algorithms designed to search for exactly the kind of narrow band coherence we are discussing. These SETI algorithms operate at much finer frequency resolution, breaking the radio spectrum into channels measured in hertz rather than kilohertz. They look for signals that persist over time, that drift predictably with Doppler motion, that exhibit the hallmarks of artificial origin, and if such algorithms detected two alternating tones lasting 11 minutes, it would have triggered immediate attention. The temporal structure of the event is particularly significant. 11 minutes is neither too short nor too long. It is long enough to rule out transient interference, to allow for multiple cycles of the alternating pattern, to provide sufficient data for analysis. But it is also short enough to suggest intentionality, a finite transmission rather than a continuous carrier wave. This brevity mirrors one of the most famous and frustrating moments in SETI history, the wow signal. The wow signal, detected in 1977 by the Big Ear radio telescope at Ohio State University, lasted 72 seconds. It was a powerful, narrow-band emission at a frequency near the hydrogen line, exhibiting all the characteristics of a distant source. The astronomer reviewing the computer printout was so struck by the signal's intensity that he wrote the word "wow" in the margin, and the name stuck. But the signal never repeated. Despite decades of subsequent observations, despite countless hours of listening at the same coordinates, nothing like it has ever been detected again. The wow signal remains unexplained, neither confirmed as artificial nor definitively attributed to any natural phenomenon. It exists in a liminal space, an anomaly that defies categorization. And the 3i Atlas Whisper, if real, occupies a similar space, a brief, structured event that appeared once, captured in data, but not yet verified through independent reobservation. The brevity of both events raises an important question. Why would a transmission last only minutes or hours? If an extraterrestrial civilization wished to announce its presence, why not broadcast continuously, ensuring detection by any listening civilization? The answer may lie in the nature of the transmission itself. Not all signals are meant to be continuous beacons. Some might be diagnostic pulses, brief announcements triggered by specific events or thresholds. For 3i Atlas, the timing of the alleged signal is revealing. It occurred on October 24th, only 5 days before the object reached its closest approach to the Sun. It's perihelion. At this critical moment, the comet was entering the region of maximum solar heating, maximum outgassing, maximum observational interest. If the object carried some kind of instrumentation, some autonomous system designed to monitor or announce its passage through stellar systems, this would be precisely the moment to activate. The 11-minute duration might represent a complete diagnostic cycle, a programmed sequence designed to transmit a specific message or set of parameters, or it might simply reflect the limited power available to a system that has been dormant for eons, briefly awakening as it passes through the warmth and energy of the inner solar system, before falling silent once more as it returns to the cold and dark of interstellar space. This brings us to the structure of the signal itself. 2 alternating tones. If artificial, this simplicity is striking. It is not complex encryption or data compression. It is not linguistic communication. It is pure pattern, the simplest possible structure that defies natural randomness. A binary rhythm, on and off, frequency A and frequency B, repeating with mechanical precision. This minimalism might be entirely intentional. An advanced civilization attempting to create a techno-signature that would be recognizable across cultural and technological barriers might choose the simplest possible encoding, not a message laden with meaning, but a pattern that announces one fundamental fact. This is not natural. This is designed. The philosopher and physicist Freeman Dyson once suggested that the first signal we detect from an extraterrestrial civilization might not be a message at all, but rather what he called a cosmic ping, a simple unmodulated transmission whose only purpose is to say, "We exist." The content is irrelevant, the structure is everything, and 2 alternating tones repeated for 11 minutes would serve exactly this function. Such a signal would not tell us who sent it, or where they are, or what they want. It would simply announce presence. And perhaps that is enough. Perhaps the first step in interstellar communication is not dialogue, but acknowledgement. A recognition that across the vastness of space and time, 2 minds, however different, have achieved the capability to listen and to speak. But we must temper this speculation with rigor. The whisper narrative, compelling though it is, remains unverified. No peer-reviewed analysis has confirmed the existence of a narrowband component in the 3i Atlas data. No independent telescope has reobserved the object and detected a similar signal. We are working from description, from second-hand accounts, from the tantalizing possibility that something was noticed but not yet fully investigated. This is why the archives matter so profoundly. The raw baseband voltage data from Meerkat, if it has been preserved at full resolution, contains every photon that entered the telescope during those critical hours. Within that data, if the whisper was real, lies the proof. And extracting that proof requires time, computational resources, and expertise. It requires algorithms that can search through petabytes of information, looking for coherence at scales measured in millihertz. It requires patience. But if the signal is found, if it can be confirmed and verified, if it passes every test in the SETI vetting framework, then the 3I Atlas event will mark the moment when humanity's understanding of the universe fundamentally changed, when we move from wondering whether we are alone to knowing with certainty that we are not, and that knowledge, however it arrives, whether as a whisper or a shout, will reshape everything that follows. For now, we listen, we analyze, we wait. Because in the space between confirmation and speculation, between the thermal broadening of hydroxyl and the narrowband whisper of intent, lies the most profound question our species has ever asked.